This is lecture 4, part 5 on systems engineering documents for Introduction to Systems Engineering and System Thinking and Analysis course. The material discussed in this lecture is prepared using multiple references, and those are listed in this slide. So the outline for today's lecture is the following. We're gonna start by discussing the systems engineering as part of project management. And then we're also gonna talk about the elements of a typical systems engineering management plan. And then finally, we're gonna talk about the systems engineering documents for the course project, which are listed in this slide in blue. So systems engineering as part of project management. Project management principal constituents are systems engineering and project planning and control. The domain of the systems engineering is technical guidance for the entire project, and project planning and control focuses on financial and contract guidance. So you can see in this figure, we have a Venn diagram which shows the systems engineering areas and the project and planning control areas, and also show the areas that are connected for both of them, meaning that task definitions, risk management, and customer interaction are both parts of systems engineering and project planning and control. Proposal development. The system development often starts with someone who has a need, which we are going to call the customer, and who requests support in the form of a request for proposal. So typically these developments, companies, agencies, organizations, they will find that they have a need for solving a problem. They don't have the expertise, or they don't have the people, or they don't know how to get started. So they put together a document that is a request for proposals, in which they request different engineers, different companies to submit the proposals in how to address the problem that they're facing. Typically, what's going to happen is there's a committee that will evaluate those proposals, and we pick the one that is the best in terms of the approach, or the preferred approach based on the committee that is in charge of making the decisions. Most of the time, there's an economic component attached to it. So it's again an evaluation of performance, expected performance, cost, and also a timeline. So a program manager or a professional team is assigned to generate the proposal. This is from the design team point of view. So you read the call for the proposal, and now you put together a team and you design this document. You put together this proposal, and you submit a proposal for evaluation. The integration of systems engineering with project management is evident in the early phases of the project, since it is essential that the technical concepts and implied design and interfaces are feasible. A statement of work is also part of project management. So a critical element of the proposal is the statement of work. This is the narrative description of the work that is needed to develop the system to meet the customer needs. The systems engineers' concerns focus on the products and services needed to complete the effort. So this has to be responsive to the customer needs. Ensures that the statement of work is based on a credible concept of operation, or CONOPS. Review the implied design for the use of legacy components and their availability. Examines to see if the proposed system concept integrates commercial off-the-shelf components and determines the technology readiness levels for the important subsystems envisioned in the preliminary design. Also, the work breakdown structure, WBS, the successful management of the system development effort requires special techniques to ensure that all essential tasks are properly defined, assigned, scheduled, and controlled. One such important technique is the systematic organization of the project task into a hierarchical structure called the work breakdown structure or the project system breakdown structure. With the system project at level 1, the level 2 items can be given as follows. First, the system product, which is the total effort required to develop the system. System support, which is the integrated logistic support. System testing, which includes all testing after component validation. Project management, which includes all activities related to project planning and control. And systems engineering, which focus on the system development activities identified in the Systems Engineer Management Plan, or SEMP. So this is a work breakdown example. You see at the different levels, what are the expectations? System support, the goal is to provide equipment, facilities, and other support for the development of the system. For example, supply support, test equipment, transport and handling, documentation, facilities, personnel, and training. System testing, the testing of the operation and the integration of the different components of the system. Individual testing of components has usually been completed, and most overall testing effort is spent in this stage. Here are some categories for testing. First, integration testing supports the stepwise integration of the system component. System testing provides for overall system test. Acceptance testing provides for factory and installation tests of delivered systems. And operational testing tests the effectiveness of the system in a realistic environment. Project management, all activities associated with project planning and control, including the management of the work breakdown structure, which includes costing, scheduling, performance measurement, project reviews, and reports. Cost control and estimating, the need to focus attention on components which deviate seriously from initial cost estimates. This is important for the overall goal of keeping the cost down. And another tool that is very useful is the critical path method, which is a network scheduling technique to trace each major element of the system through the engineering of its critical path parts. In this, estimates are made of not only the size, but also the duration of effort required for each step. The particular path that is estimated to take the longest time to complete its activities is what we call the critical path. The systems engineering includes the activities of the systems engineering staff in guiding the project through all its major phases, such as requirement analysis, trade-off studies or analysis of alternatives, technical reviews, test requirements and evaluations, system design requirements, configuration management, and so on. These activities are part of the SEMP. So this is the SEMP in Program Management Plan. So you can see how the Systems Engineering Management Plan is in the middle of the program requirements, the project management plan, the program management requirements, and the program technical requirements. So this is the heart of this plan. Now let's transition to the systems engineering documents for your course project. So for the semester project, we will focus on the following 8 systems engineering documents. These are documents that you have to generate as part of your final report for your course or for your class. And these are the 8 documents. We're going to go and discuss most of them today. Some of them will be saved for later this semester, specifically those document 6. So let's talk about those. First, the problem situation. In here, you have the executive summary, which states the problem, describes the customer and the stakeholders. And in the final version, it describes the preferred alternatives in terms of recommending the design for your system. Also highlights performance, cost, schedule, and risk. This document is intended for management and the public. Problem situation. Complete the problem statement before defining the requirements. Avoid stating the problem in terms of solutions. If you can, involve the customer in the process of defining the problem and the requirements. This is the foundation for a successful project. Early in the system design, consult all stakeholders, including manufacturing and reliability, availability and maintainability, about the system requirements. Stakeholders are people who are going to benefit from the system to be designed or those who will be affected by it. So start building while you're still designing. Number 2, our document, or the second document, is customer requirements. This is the detailed problem statement and is based on the specific requirements sections of the use cases. Recall what we discussed in our previous lecture in terms of how do you write the requirements. So in here, you will have a set of requirements for your system in this document. And this document is intended for management, the customer, and systems engineering. Document number 3 is the detailed requirements. This is the technical description of problem statement, system design requirements, trade-off, and the test plan. Typically will involve some type of verification matrix. So you will use this to make sure that you are covering all the areas of your system. And this is intended for engineering. System validation shows that the system and the set of requirements satisfy the actual customer needs. So it checks the set of requirements for consistency and completeness. Shows that a system model can satisfy the requirements and ensures that a real-world solution can be built and tested to prove that it satisfies the requirements. Recall our discussion in terms of functional system design, buildable system design, and implementation system design. This document is intended for systems engineering. Recall that validating requirements mean ensuring that the set of requirements is complete and consistent. A real-world solution can be built that satisfies the requirements, and it can be proven that a real-world system satisfies the requirements. If the requirements specify a perpetual motion machine, then the project should be stopped because there's no way that you can create something like that. So that's just an example. Each requirement must be verified by a logical argument, inspection, modeling, simulation, analysis, testing, demonstration. In some way, you have to make sure that this is verified. Concept exploration, investigate alternative system designs. So for example, you have alternatives A, B, and the do nothing alternative, meaning that you will stay with the system that you have in place. Shall use new unproven technology, these alternative system designs. Produce incipient initial architecture in the concept exploration, and use evaluation criteria in trade-off study. So for example, performance figures, cost figures, trade-off figures of merit, and risk, measuring the risk of using new or improved technology. In this concept exploration, you can present sensitivity analysis, and also you should explain the do nothing alternative. This document should be readable by the public. As I mentioned, when we listed or when we discussed the list of documents, this one, I'm gonna save the discussion for later because we're gonna have a lecture just on developing the use case models. So this is coming at some point, but the idea here is that you create these diagrams that are going to allow you to have a better perspective of the users of your system and how are they connecting with your system, how are they interacting with your system. And by developing these diagrams, you get a better understanding of what are the things that the system must cover. So you perform functional decomposition, in which you transform an input into an output, and you decompose top-level system functions into sub-functions and into sub-functions and so on. So you create these diagrams, they illustrate all this, and by creating these diagrams, you start learning about, okay, pieces of information that you might be missing, or areas that you haven't considered that are important for your system. So this is intended for management, engineering, the customer, the public, and systems engineering. So as I mentioned, use case models can help you discover a function the system must perform. Will list an input that will be transformed into an output, and so on. So here are some examples. If you want to look at them, as when you study these slides, these are relevant in terms of what we are going to discuss when we get to the use case models. Also, designing a model and this is document number 7. So you want, again, most of the time when you're creating a system, the type of system that we are creating for this project are new, are novel. They have not been implemented before. So the way that we test the performance is often through the development of models. So document number 7 is basically guiding or describing a model that you are going to create to describe the functions of your system. So we are also going to spend some time discussing this, but document number 7 is going to, there's a lecture on this, but the idea here is that you develop a model in a mathematical way. You are going to define your model, and it's going to describe the functions of your system, the input, the outputs, the functions, and this can help you verify the performance of this new system, novel system. This is intended for systems engineering. Okay, so again, we're gonna touch on this later on this semester, but it's important that you start getting familiarized with them. This type of diagrams, sequence diagram, state chart diagrams. And then finally, we have the mapping and management. So this is more in terms of connecting these 8 documents. You're making sure that they have some type of link. So for example, between the requirements of document 2 and document 3, and there's some mapping between verification of document 3, evaluation criteria of document 5, and between the functions of document 6 and the objects of document 7. And this is a good table. I like this table because it tells you the order in which you should start these documents, and then the order in which you should finish them or complete them. So as you can see, document number 1 is the first one that you start, but you have to wait until you complete the project to finish that document. Number 8, document 8 is the second document that you're going to start, but again, is the 7th document that you end, and so on. So in summary, we talk about project management and systems engineering as part of project management. We also discuss the elements of a typical systems engineering management plan. And we talk about the systems engineering documents for the course project.